Welcome to Lecture 1.2, Power System Future Infrastructure. Today we're comparing different power system topologies and look into the transition from the existing, traditional, to a future, modernized power system infrastructure. Right now, many things in the power system are centralized. Centralized design has often quite some advantages. Typically, it's more efficient. If you design something in a centralized way, you benefit from the economy of scale, and things are also much easier to organize in a centralized fashion. There might be some limitations with regards to flexibility or scalability, but in general, it works and is efficient by nature. That's why it was done like this. One downside of centralized design is less technical, potential monopolies, which in turn leads to less efficiency. The other extreme is a completely decentralized infrastructure. So every load gets its own generation. My home is my castle. This might look appealing at first glance. You can do targeted, made-to-measure solutions for each and every load, but it's not efficient either. You cannot share problems, you cannot share solutions, and you cannot help each other. Helping each other is extremely important when you deal with limited resources. Fully decentralized is also not social. The rich guy gets the good supply, the poor guy does not. This is not what we want in a modern society. Let's pick the best of both worlds, a distributed system. Partly the power system is already a distributed system. There are multiple generation units meshed out there, and they share the burden of supplying the loads. If one generation unit fails, another one can kick in. This is largely market-based, so there is a certain amount of competition, which is what we want. And right now, we have the ability for an even more distributed system, where even small generation units and the load side can also join the game. Most notably, rooftop solar panels. It can lead to the best of both worlds. Sure, it needs quite some thinking, quite some planning, and operations get a bit more complicated. But the digital transformation is our friend here. Data helps to organize such systems in planning and in operations. How is this done? There are many things to do, of course. Here's just one example of a smart load-side generation and storage infrastructure. It would constitute one node in a distributed power system. In this example, we have some photovoltaic generation units. You maybe need some storage on site to balance day and night. In this case, it's a battery. And you need some seasonal storage between summer and winter. You might need something else, maybe on a larger scale, maybe on substation level or on national level. Such a mix is exactly the winning combination for a distributed system. The enabler is smartness. You need some energy management system that does scheduling, that does forecasting, and that uses the degrees of freedom that you have for yourself and also as a community together with others. So today we saw that two extremes, centralized and decentralized topologies, both have pros and cons when it comes to infrastructure, resilience, and efficiency. We also saw the distributed approach, where the disadvantages of the first two options are overcome with the help of smart digital controls.